Find the third derivative, y triple prime, or d cubed y dx cubed, for the function y equals sine squared x. Then evaluate y triple prime of 3 pi over 4. So y here is a trig function raised to a power, sine squared of x. We will want to rewrite this as sine of x to the power of 2 to remind us of how to take the derivative. The first derivative, y prime, or dy dx, will be, start with a power rule. We'll bring the power down, leave the inside alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. So we have 2 sine x cosine x. Our second derivative will involve a product rule then. We will have the 2 times the derivative of the first, cosine x, times a 1 for the chain rule, and then times the second left alone, plus the 2 times the first left alone, times the derivative of the second, which is a negative sine x, times a 1 for the derivative of the inside to complete the chain rule. And we have 2 cosine squared x minus 2 sine squared x, which we may want to rewrite as 2 cosine of x and then squared, and 2 sine of x and then squared, to remind us of how to take the derivative, because we are going to the third derivative here. Y triple prime, or d cubed y dx cubed, equals, now for the first term we have the power rule. Let's bring the power 2 down, multiply with the 2 in the front of 4, leave the inside alone, cosine of x, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. And then for the second term, the same thing. We'll bring the 2 down, it's power rule to start things off, multiply with the negative 2, so we'll have negative 4, leave the inside alone, subtract 1 from the power, it will be to a power of 1, and then multiply by the derivative of the inside of the power to give us cosine x to complete the chain rule. So the first term, I have a negative and a 4. Let's put those together. Everything's multiplied there, so negative 4. And I'll write the sine first and then the cosine. Everything's multiplied, so the order doesn't matter. And then the second term, I also have a negative 4 sine x cosine x. So these can combine to negative 8 sine x cosine x. And there's our third derivative, y triple prime, or d cubed y dx cubed. Now it turns out that each of these derivatives had a double angle identity in reverse that could have been done for them. And I will show the results for each of these if this were to be done. The first derivative, back up here, 2 sine x cosine x, that could also have been written as sine 2x. As a matter of fact, you can do that and take the derivative from there instead. The second derivative, and where we were getting a 2 cosine squared x minus a 2 sine squared x, that 2 can factor out, and cosine squared minus sine squared is actually a double angle formula on cosine, and that will be cosine of 2x. And then just the same, our third derivative, we have once again a sine of x times a cosine of x. We need a 2 with that. 2 sine x cosine x will give you sine of 2x, but we'll borrow a 2 from that negative 8, leaving a negative 4. And so this could also have been written as negative 4 sine 2x. And there's the double angle formula versions of each of those. So each of those did simplify. Anyway, we want to now evaluate y triple prime of 3 pi over 4. I'm just going to use the original version of our third derivative in case you don't see the double angle formula for it. So I will have a negative 8 sine of 3 pi over 4 times the cosine of 3 pi over 4. Now 3 pi over 4 is the second quadrant equivalent of pi over 4 in the unit circle. So the sine is still a positive, and just like at pi over 4, it'll be root 2 over 2. And the cosine is just like pi over 4, except we're in the second quadrant, and cosine is negative in the second quadrant of the unit circle, so negative root 2 over 2. So I have negative 8 times. In here, let's multiply the numerators. Root 2 times root 2 is a 2. We have that negative come along with that. And then the denominator is 2 times 2 is a 4. We can now multiply the numerators there, negative 8 times a negative 2, which is a positive 16, over, multiply the denominators, we just have the 4, and then 16 over 4 equals to 4.